Dear students, welcome to today's class. Today we will start first lesson of physics, grade 12. Chapter name is Electric Fields and Charges. So the first two chapters together known as electrostatics. The word electrostatics, statics you all know, at rest. Okay, study of objects at rest, that is meaning of statics. Electro means it is associated with the charges. So in this chapter we study about charges at rest. Electrostatics is the branch of physics that deals with the study of charges at rest. In this chapter, we will discuss about forces arising from static charges, electric fields arising from static charges, potentials arising from static charges. These are the things we are going to learn in this chapter. Okay, so last year you have learned the chapter gravitation. There we learned the gravitational field, the gravitational potential, gravitational force, all these terms. So here also definitions and derivations are similar. Okay, so it will be easy for you to understand. So what is electrostatics? Electrostatics is the branch of physics that deals with the study of charges at rest. We will study about forces, fields, and potentials arising from static charges. And what do you mean by charge? You know, all materials are made of atoms. Atoms contain electrons and protons. And you know, protons have positive charge. Electrons have negative charge. Then what is this charge? Two electrons can repel each other. You know, two protons can repel each other. A proton and electron attract each other. Okay, so there is a force between electrons and protons. So charge is that property which gives electrons and protons a force between them. So what is electric charge? It is the property of electrons and protons which give rise to a force between them. And you know the positive, two types of charges, positive charge and negative charge. Charge of an electron is taken as negative charge. Charge of a proton is taken as positive charge. So these are the two types of charges. So what do you mean by charge? Charge is the property of electrons and protons which give rise to a force between them. And there are two types of charges, positive charge and negative charge. Charge of an electron is taken as negative charge. Charge of proton is taken as positive charge. Charge we can measure. The charge has a unit. The SI unit of charge is coulomb. We denote it by the letter C. So our chapter name is Electric Fields and Charges. Electric charges and fields. Electric charges and fields. Okay. This is the chapter 1. Charge. What is charge? It is the basic property of electrons and protons which give rise to a force between them. The charge of electron are taken as positive. Charge of electron is taken as negative. It was arbitrarily taken initially. Okay, charge of electron is taken as negative and proton is positive. And charge is a quantity that is measurable. The SI unit of charge, electric charge, is coulomb. We use capital letter C for it. The basic unit of charge is the charge of proton or electron. Okay, what is the basic unit of charge? Charge of an electron or proton. The basic unit of charge is the charge of electron or proton. Okay, it is given as 1.6. We represent it E. Okay, plus or minus 1.6 into 10 raised to minus 19 coulomb. This is the charge of electron or proton. Charge of electron is minus 1.6 into 10 raised to minus 19 coulomb. Charge of proton is plus 1.6 into 10 raised to minus 19 coulomb. If an object loses electrons, it becomes positively charged. If an object gains electron, it becomes negatively charged. Okay. So when charge is transferred from one object to another object, there is a transfer of mass, right? Because electrons and protons have mass. That is the reason. Okay, there is when an object is charged negatively or positively, there will be a transfer of mass also. Now we will come to the properties of charges. First property, you all know, if two protons are brought together, what will happen? They will repel. Okay, if two electrons are brought towards each other, what will happen? They will repel. If a proton and electrons are brought near to each other, what will happen? They will attract. So like charges repel and unlike charges attract. This is the one property. First property, like charges repel, unlike charges attract. And second, charge is a scalar quantity. It has no direction. Okay. So charge is additive in nature. The total charge on an object is equal to the algebraic sum of all the charges on it. So second, what is the second property? Charge is a scalar. You know what is a scalar quantity? No direction, right? Charge is additive. Additive in nature. What is the meaning of charge is additive? If an object contains many charges, positive charges, negative charge, all type of charges, total charge will be the algebraic sum of all the individual charges. This is the meaning of charge is additive in nature. Then third property, charge is conserved. Total charge on an object is constant. We cannot create or destroy charges, but charges can be transferred from one object to another object, right? If an object loses electrons, it becomes positively charged. No new charge is created there. Electrons are transferred to some other object, right? This is the meaning of charge is conserved. Charges, total charge on an object remains constant. Okay, it cannot be created nor destroyed. So that is a third property. Charge is conserved. Charge is conserved. Now, fourth property. Okay. This may be a new word you are going to hear, quantization. Charge is quantized. What is the meaning of quantization or quantized? The word quanta means small amount, small packets we can say, small amount, as fixed amount, that is known as quanta. So charge on an object is an integral multiple of a basic unit of charge. This is known as quantization. An object can have a charge equal to an integer into a basic unit of charge. A basic unit of charge, it is a fixed amount of charge. Basic unit of charge we take as charge of an electron or proton. This phenomenon is known as quantization. That basic unit of charge is very small. You take charge of an electron as 1 coin. Imagine, 1 coin is 1 quantum. Quantization. Okay. So what is quantization? Charge on an object is an integral multiple of a basic unit of charge. This is known as quantization of charge. The charge on an object is equal to an integral multiple of a basic unit of charge. So mathematically we can write Q is equal to plus or minus NE. What is this N? N is an integer. 1, 2, 3, 4, etc. N cannot be 0. Okay, N is an integer. And N cannot be fractions. 1 by 3, 1 by 2, like that. This experimental fact, this is known as quantization of electric charge. Okay. So these are the main properties of electric charge. So what are the properties? Like charges repel, unlike charges attract. Charge is a scalar quantity. It is additive in nature. Charge is conserved. Charge on an object is equal to an integral multiple of a basic unit of charge. N is equal to Q is equal to plus or minus NE. What is N there? An integer. N can be 1, 2, 3, 4, etc. Now, one important thing you have to remember. This quantization of charge, this is valid only for very small number of charges. small amount of charges, or we say it is valid in only in microscopic approach. Microscopic, microscope, it is very small, right? Microscopic approach. So this quantization is valid only when charges are in small quantity. What will happen if the charges are in very large amount, say millions of charges, billions of charges? Then what will happen? In that case, you will see that the charges are very, very close. Charge of one electron is very small and they are very close. They will appear continuous on the object. So charges will lose their grainy nature. Okay. If you pour one drop of water on a table, 5 drops of water on a table, you can count it, right? Okay. But if you pour millions of droplets on the same surface on the table, what will happen? They appear continuously, right? Same way. Okay. So this is important point you have to remember. Quantization of charge is valid only in microscopic approach. Quantization of charge is valid in microscopic approach. What is microscopic approach? Charges will be small in amount, right? In number. In macroscopic approach, we will ignore what? The quantization. Macroscopic means charges will be in very large amount, millions of charges, okay? It is valid in macroscopic approach. Okay. Why it is not valid in macroscopic approach? Because of very large amount of number, very large in number, they loses the grainy nature, they appear continuously. Okay. These are the properties of charges. Now, I told you the SI unit of charge is coulomb. Okay. So these are the properties of charges. Now, we can charge on an object. There are some methods for charging. First one is charging by friction. Charging by friction. See, actually, the word electron, it is coming from, its origin is from Greek. The word electron. Electron. But electron we use CTRON, right? In Greek, electron. Actually, this has origin from the material called amber. Greek amber, it is electron. In Greek, amber, the name is electron. If you take 2 amber pieces, rub each other, and you show 2 pieces of small bits of paper, we can see that the amber, after rubbing, could attract the paper pieces. So the amber got charged. So they developed an attractive property, right? And after rubbing, if you show 2 amber pieces, they will repel. That is why they are charged. Okay. So the amber Greek name is electron. From that only the word electron came. So this is one method of charging, rubbing. During rubbing, what is the force involved? Friction. So this type of charging is known as charging by friction. And the electricity developed is called static electricity. Many examples are there. You take a comb, plastic comb, rub on your hair. After rubbing, if you show two small bits of paper, what will happen? The paper get attracted. Why? Comb got charged. Okay, this is another example. Again, I will tell you, you take two glass rods, rub it with the silk cloth. After rubbing, if you bring the glass rods towards you, towards each other, you can see that they are rubbing. But you should not use your hand. You have to suspend by silk thread the rods. Okay. If you hold on your hand, it may discharge through your body. Okay. So by rubbing, charges can be created. When glass rod is rubbed with the silk cloth, the glass rod appears positively charged. Silk appears negatively charged. So what happened when you rub? Due to the frictional force, some of the electrons are transferred from one object to the other object. That is how they got charged. Here glass rod lost some electrons. That is why positively charged. What about silk cloth? They gained some electrons. So silk become negatively charged. Here charges are not created nor destroyed. Total charge is same. Only charges are transferred. Okay. So methods of charging. First method I told. What is the methods of charging? First one, charging by friction. Second method, charging by contact or conduction. So charging by friction, two examples I told you. One is rub your dry hair with a plastic comb. The objects are get charged. Another two glass rod silk with a glass rods rubbed with the silk. Glass rods and the silk cloth become charged. Okay. One more example I will tell you. You take some paper strips. With your iron box, you iron it. And you bring the paper piece to the in front of your TV screen or a monitor screen. You can see the paper there. It is attracted towards the TV screen. Same thing happened. Charging by friction. Okay. There are many examples. So charge will be transferred from one object to the other. When you rub the glass with the silk, electrons are transferred from glass to silk. That is why glass appear positively charged. So on which object electrons are loosely bound, that from there it will be transferred to the other object. Okay. So second method is charging by contact or charging by conduction. When a charged object is kept in contact with another uncharged object, the charge will flow from one object to the other object till they attain an equilibrium, right? This is charging by contact. Now, one more method is there, charging by induction. Okay, charging by induction. Third method is charging by induction. What is this induction? See, you take a positively charged object here. See, this is a metal sphere. I gave a positive charge on it. Okay. It is kept on an insulating stand. Insulating stand means charge should not lose to the earth. That is why. If you keep another uncharged sphere, or you can consider two bodies also, any bodies, okay? This is also kept on insulating stand. You know, this positive charge, they like the electrons, right? They attract the electron, right? Positive charges are very fond of opposite charges, right? So this positive charges attract the electrons. Due to that attraction, electrons will move to this side, move to the near side of this object. So electrons all will come and sit here, right? Electrons left from the other side, right? So one side is negatively charged, other side is positively charged, right? This phenomenon is known as induction, electrostatic induction. Okay. So in induction, opposite charge is induced in an object near to the charged object. That you have to remember. These are called induced charges. Now what we have to do is, now the second object, okay, you connect to the earth by a wire. This is known as earthing. Okay, so here negative, here positive. Connect to the earth. Earth we represent by this letter. So what will happen? Electron is, earth is an electron bank. Lot of electrons are there. You can deposit and take electron from the earth. That is known as, that is why it is known as electron bank. So the electrons will move from the earth to the object and neutralize all these positive charges. Okay. Now only negative charges left with the second object. I take this A, object A, this is B. A, object B. Now you remove the first object away. Now disconnect. After it is neutralized, disconnect from the earth. But A should be near it. After disconnecting from the earth, you remove A, move away A. Then what will happen? The negative charge will be uniformly distributed on the sphere B. This is how you are charged an uncharged object with negative charges. Okay. You can charge by induction. This is by the method of induction. You can charge an uncharged object positively. How? In that case, the charged object that has to be placed near the object B should be a negatively charged object. Okay. Suppose in this case, A is given negative charge. Okay. This is B. So by induction, here positive charges. Negative charge repel the electrons. Push the electrons. So electrons will go to the opposite side. Now you have to earth this. In this case, electrons will move to the earth. Okay, electrons will move to the earth. Electron will, during earthing, what will happen? Electron will move to the earth. Electron will move to the earth. Now unearth it. Then remove A. Then the object B will be positively charged. Okay. This is charging by induction. So today what we learned, now we got an idea about charge. What is charge? Charge is the property of electrons or protons which give rise to a force between them. And we learn charges, properties of charges. What are the properties? Like charges repel, unlike charges attract. Second property given, charge is a scalar quantity. It is additive in nature. Total charge on any object is equal to the algebraic sum of the individual charges. Third, charge is conserved. Charges can neither be created nor be destroyed. Total charge remains constant, but they can be transferred from one object to the other object. Next property, charge is condensed. Total charge on an object is an integral multiple of a basic unit of charge. What is a basic unit of charge? Charge of an electron or charge of an electron or charge of a proton. Okay. And now again learn three methods of charging. Charging by friction, charging by induction, charging by conduction. So today's class, I am going to stop today's class. So we'll discuss remaining in the next class. Thank you for watching.